Hello everyone. In this video lesson we are going to speak about data link layer of OSI model. But first of all we'll make a review of previous layers of the same model, and let's start of reviewing this model from the example of Matryoshka, in which we have the data. Afterward, data is encapsulated into the segment or datagram. After, our Matryoshka is encapsulated into the packet. And from the packet, it is now becoming the frame. After frame, it will be represented in bitstream and bit code, and afterward it will be signalized. And now, if we will make comparison of these matryoshkas with OSI layered model, then we'll have an application, presentation, and session layers. Our segment or datagram is placed on layer which is called the transport layer, and the packet in network layer, and the frame in data link layer. And the rest part is the physical layer. In segment we have a type of addressing which is called the port addresses or the port numbers. In packet we had with you explanation of IP version 4 and IP version 6 addresses. And in frame, in data link layer, the addressing is the MAC address. And MAC address is actually the physical address. And IP address can be called logical address. And layer 7 to 5, L4, L3, and layer 2 and layer 1. So today we're gonna speak about layer 2, the data link layer, which actually consists of two sublayers, whereas one sublayer is the part of the software implementation, and second sublayer is the hardware implementation. Whereas the functionalities of the data link layers allows the upper layers to access to the media using techniques such as the framing, and control how data is placed onto the media and is received from the media using techniques such as the media access control and error detection. And as you see here, the PC NIC is the element of the layer 2 device. Actually, this is data link layer device, networking interface card. And so look, data link has two sublayers. It is the only one OSI modeled layer which has sublayers. The sublayers are called logical link control, LLC, and the media access control. Whereas logical link control places information in the frame that identifies which network layer protocol is being used in the frame. So it can be IP version 4, IP version 6, or it can be any other layer 3 OSI models protocols like IP security, etc. And whereas media access control provides data link layer addressing and delimiting of data according to the physical signaling requirements of the medium and the type of data link layer protocol in use. So these two sublayers are working together and they are creating the data link layer. Data link layer creates the frame, and frame consists of the header, the packet, and the trailer. So all the previous encapsulations been only with the headers, like you had data. To data we added the segment header. Afterward, this became the segment plus a packet header. Now it was called the packet. And this packet plus header and trailer is a frame. What do we have in the header? In the header, we have a frame start. So this is a spatial sequence of the bits, a unique sequence of bits that defines that this is the beginning of the frame. We have addressing, whereas addressing is used, for example, it is 48 bits, or we can say 6 bytes. And it is MAC address, which is looking like 1 1 1 1 1 1 and 2 A B C D E. This is example of MAC address. So here we store source MAC address, from which device it is coming, and destination MAC address, to which device it is going. Well, we have also the type of the upper layer protocol, for example, IP version 4 or something like this. We have quality control, which is actually can be written as the COS. We can define the priority of each of the frame, which are exiting through the network interface card. For example, if it is door, and this is our NIC, and this is network connectivity, and your signals has to be passed like this. I mean, your frames has to go by using this directory. And in case if you have frames in the queue, like 1, 2, 3, and 4, maybe fifth frame will be very important. Okay, its priority can be just place it in the quality of quality control, and then it can pass without waiting of these guys. Well, we have data. Actually, this is not data. This is the packet. But inside the packet, we have data. In the trailer, we have error detection. Whereas in error detection, we have value which is called a frame check sequence with its content of the CRC, cyclic redundancy check, with its checking of the frame errors, and if a receiving device, for example, computer A, is receiving the frame, so computer A calculates the CRC value by itself and makes comparison of the CRC value which is placed right here, and if they are same, then okay. If they are not same, then frame is deleted. And also we have the spatial pattern which is defining the frame stop. Okay, so when device will read the last bits, it will understand, oh, okay, this is the end of the frame. And when it will read the first pattern, it will define, oh, this is the beginning of the frame. Data link standards. In data link, we have different standardization organizations like ISO, like IEEE, E2, and ANSI. And mostly we'll work with you with the IEEE standards. They are LLC, this is logical link control sublayer. This is the Ethernet 802.3. This is current technology which is used in our local area networks. And we have token ring, which is not used anymore in most of the organizations, and the wireless LAN with 802.11 standard. ISO, International Organization for Standardization, Institute of Electrical and Electronics Engineers, American National Standard Institute, and International Telecommunication Union. Let's take a look for the media access controls. We can have two scenarios where we don't have any control. So at this moment, any device will send information at any time, and there will be a lot of mistakes. It's like a crossroad without the street lights. And we can have the control based. So we can have somehow to control the media access. So it is consisting of two parts, control it and contention based. And if we'll take a look for controller type, when we use controlling access method, network device take turns in sequence to access the medium. And this method is also known as the scheduled access or deterministics. And let us take a look for such kind of example where we have 3 or 4 people which are trying to make communication, and imagine that they have the schedule. For example, A will make communication at the first minute, B will make communication at second minute, C at third minute, and D at fourth minute. And they will communicate in this way, so that this person A will say that, hey, uh, can you say to person D that I would like to communicate with him? And he will say, can you say to D that A wants to communicate with him, and so on. Okay, so that we will make communication by schedule. After 1 minute, when we'll have the seconds minute time, by the schedule, this device will make communication, and communication will be happening like this. And all the time, so every device, every person in this topology will make communication only at that time when it will have its own order to make communication by the spatial schedule, and control it method of the controlling the media access can be compared with the relay race example, where the sportmen's where the athletes are running from one team. Only one athlete can run, and the token in the hand of the person is just gives the rights to run. So when one athlete will come to the end of the circle, another one will take the token and start to run. So example of control is the relay race. And the token ring, one of the example of controlled media access control method, in which all devices being connected also by the circle, and they being connected. So each network interface card had 2 ports, one input, one output port. Okay, and device A sending the information to device B, so that device B sends its information to device C, and the receiver, for example, device D. And at this time, only one device is able to communicate. Others are waiting for their own order, and afterward B starts to communicate, and so on. What are benefits of using of this type of the media access control is that there was no collisions. Okay? Why there was no collisions? Because in order type of communication, due to that fact that we have order, we don't have collisions. It is the benefit, one of the benefit of the usage of the controlled media access control. But we have disadvantages that we have to wait for our turn to start to make communication, and if something wrong will be with one of the link or with one of the network interface card, there will be no network connectivity. So this is one of the biggest disadvantages. And imagine that you have not 4 devices, but you have about 20 or 30 devices which are connected to single network. So then if one problem will be happening in one device, then all devices, it will be impacted to all devices. Contention-based type of communication, also referred as non-deterministic, and contention-based method allows any device to try to access the medium whenever it has data to send. And let's take a look for an example. We have with you computer A, computer B, and computer C, which are interconnected by the link, by the bus. Or let's also have computer D. So imagine that this is electrical line, and if one of these devices is generating the communication, this is our electrical signals. So these electrical signals will go to computer C, will go to computer D, and will go to computer B. Why? Because it is shared media, and in shared media we have such kind of rules like physical rules. Okay, and what is happening when computer A wants to send information to computer B? Actually, first thing what computer A has to do, first thing, it is a listening for the media. Listen for the media. Because if someone else will communicate through this media, computer A will sense it because it is electrical signals. And if there is no any other communication in this media, computer A, or maybe, so let's have an example. If someone already makes communication, computer B is making communication, so that computer A can hear it. Computer A will wait for a while. After waiting for a while, maybe this communication already finished and computer A will listen again. And if there is no communication, then no communication defined, then we have another step, step 3, let us say, to which we can skip. Computer A is sending the information, electrical signals. And at that moment, no one else can make communication in this network, but it can be situation like this. Imagine that computer A and computer B wants to send information. They have idea, oh, I have to send information. Oh, I have to send information too. And both of them are listen for a media. And no one else is sending information at this time. And they don't feel each other that they are listening for the media at the same time. And they start to send information at the same time, which will go to computer C, and which will go to computer D, and their signals will meet each other, and here will be boom. So this is collision. Collision happened. It is like, it is like an accident between two signals, and when it will be happened, all devices will sense it. All devices will sense it, and after they will sense it, they will place a spatial timer to be started to be on, and it's like here was the send signal. Now the fourth step, if something went wrong, I mean if we have collision, then we have a back-off timer. And back-off timer is the spatial randomly selected amount of time on each of these devices. And it is back-off timer. It means that countdown timer, and each of the device selecting, for example, 10 seconds, 9 seconds, 11 seconds, and 12 seconds. So after computer B will expire its own timer after 9 seconds, this computer B will start to listen for the media again. And when it will start to listen for the media one more time, if there will be no other communications inside this media, then computer B will send the information. Okay, but there is no guarantee that they will not get the 9 and 9. So if they will get 9 and 9 and they will send information, they will listen for the media and they will send information one more time, and here will be boom one more time, and this algorithm will start to work one more time. So this algorithm is called the CSMA CD, carrier sense with multi-access with the collision detection for the Ethernet networks. And it is working only in case when you have computers, like I had an example, previous example, like A, B, C, and D, and when they are interconnected by the device, which is called hub. Oh, hub doesn't have any addressing, so that is why. So physically, your topology can be shown like this, but logically your topology will be seen like this. Okay, so that physically it is star topology, but logically it is a bus topology. So let me write it here. Bus topology. And physically it's going to be the star topology. Oh, this is actually contention-based method of the media access control in data link layer. What are advantages of this type of network? That we don't have to wait for our own turn by using schedule. What are disadvantages? That there can be happening a collision, and when collision is happening, then we are waiting for the CSMA CD mechanism to just prevent the collisions, not to prevent, to just avoid, or not to avoid, to uh, detect the collision and try to resolve the situation and try to send information one more time. Okay, so that modern Ethernet is working with this CSMA CD mechanism in case when you are connected by using a hub. When you don't have the hub connectivity, but you have instead of hub a switch connectivity where your devices are connected in this way, then you don't have this mechanism because you have the full duplex communication, but in half but hub has the half duplex communication. So let's take a look what is the duplexes in the network. So the half duplex means that when you have communication to one side only, and you can just send information after you already send information. Now you can receive the information by the order, by the queue. But in full duplex communication, you can send information at the same time when you are receiving this information. And the full duplex communication is example of the fast Ethernet and gigabit Ethernet, and the half duplex communication is the example of just an Ethernet 10 megabits Ethernet, which is used with the hub topology. What are differences between logical topology and physical topologies? So logical topology is an arrangement consists of virtual connection between the nodes of a network independent of their physical layout. And here are some logical topologies like point-to-point topology, like when one point is connecting with another point, multi-access topology, or as I mentioned before, it can be called bus topology, and ring topology, which is describing the docking ring topology. So physically bus topology, well, you will not have physical bus topology, but physically you will have the star topology mostly. Okay, so this is going to be the star topology. And the physical topology is an arrangement of nodes and physical connections between them. The representation of how the media is used to interconnect devices is the physical topology, and this will be covered in later chapters of this course. I think that it will be covered right now. So let's take a look for an example of the PPP topology. The PPP is like a point to point connectivity, and when you are connecting for example one computer to another one, so like one point and another point, or it can be situation when you connect one router to another router, like one point connected to another point. So logically PPP is looking like this, but physically your PPP is not actually PPP because it is connecting from one point logically to another point, but physically they will have much more interconnectivities. Okay, so you have here some different passes between these points and so on. Multi-access topology, it is same as I mentioned before, it's like a bus topology. And this bus topology is actually it's physical type of it, but logical it is multi-access topology. Alright, so that if we'll take a look for the small animation, we may find out with you for how the information is traveling on the with the help of the CSMA CD. Let's take a look for it. Computer A wants to send information to computer A, and it's detecting that computer A is not seeing any signals, and it is just sending the frames. All of the devices are receiving this frame, but only computer A sends the reply, make a reply. and computer B at the same time wants to send information, and is sensing that there is some communication happens, and now after this communication finishing, computer B will send its own information. And there can be situation like two devices can send information at the same time. I think that is not listed in this example, so we'll have maybe it later, but I already showed you. And the ring topology. Okay. Now the very important information that when our frame is traveling from one network to another network, the frame structure is changing out. And let's take a look for a small example. When computer sends information with look LAN header and LAN trailer, it means that the header of the frame and the trailer of the frame, and it was the packet between them, and now it is becoming the one header and one trailer. So the new header of the frame and new trailer of the frame, and between them it was also the packet. The packet is absolutely same packet as it was here and here, but the headers are different. And now let's take a look for the small example which I prepared for you to explain why the frame header and frame trailer are changing. When we are sending information, we start to generate this information from the application layer, and afterward it goes to layer number 4, and on layer number 4 we have a division of our data into small pieces of data, plus to each of this division we add the source and destination ports. And imagine that we are contacting to port number 80. It's an example of the HTTP communication, and with the source port 1027 as an example. And next, so look, segment header plus data will become a segment on first layer, and afterward our segment goes down to layer number 3, in which we have source IP address, which is actually equal to this value. So this is our source IP address, look, and our destination IP address is written inside the packet header is 222 and 20. Afterward our segment plus IP header becomes a packet. Our packet goes down to layer number 2, and our packet now becomes a frame, where our frame consists of consists of the frame header, the packet, and the frame trailer. Where in the frame header we have information of the source MAC address, which is equal to, so let me define the source MAC address with different color. It's going to be the red one. So this is our source MAC address, which you see right here, and destination MAC address. Are you surprised? Maybe you think that destination MAC address is going to be here, but let me tell you, the MAC address is used locally. So MAC address used for local communications. Communication inside one network. So when we are sending information from computer A to computer B, we send information to IP address of computer B, but we send our information to MAC address of our gateway if we are communicating with different networks. So this is our gateway, and we send information to MAC address of our gateway. What happens next? Our frame goes to the router. But by the way, first of all, it goes to the switch, and switch receives this frame, and afterward it is making comparison of the frame header with this MAC address. Okay, it make comparison of this MAC address with this MAC address. Okay, and this MAC address switch has to have in its own MAC address table. According to this MAC address table, switch will define where to resend this information, and it is defining that, okay, I will send this information to through FA02 port, and it's like, okay, you go like this. Next, what happens next? Our bit stream or like signals are going to router. Router receives this frame, and router deletes the part of the frame header and the frame trailer and looks only for IP addresses. Because router is working on layer 3 and layer 3 works with IP addresses, and routing table consists of source port and destination port. And when you have the destination port, destination IP address, I'm sorry, which is matched from the packet header, router defines where to resend this information, okay, through gigabit 01. So our information will go like this. But before it, our router will do what? Will create a new frame. So this is new frame in which source MAC address, look, who is the sender now? Source MAC address is interface of gigabit 01, and destination MAC address is IP address of our computer. Okay, so look, before we had source MAC address, this one, and destination MAC address being like this. But now in new network, we have new frame, header and frame, trailer, but the packet is absolutely same, right? So that it will be sent to switch 1. Switch 1 will also take a look to its own MAC address table and will define to which port to send this destination, where is place this destination's MAC address. And actually it is, you see, and FA02. And our frame will be sent through FA02 to the destination. And this is how communication happens. So that computer 1 or computer receiver will get this information, will make decapsulation, and until the data. This is how we have the communication through the network, including all the layers which we studied with you before. Now let's take a look for the review of the MAC address table. MAC address table consists, so it's a physical table, so we may say, we have to say this is physical address in comparison with IP address, which is logical. This is physical one. It is divided into two parts, whereas one part is called the OUI, Organizational Unique Identifier. This part identifies the vendor. Vendor ID. Vendor, it is the company which is producing this device. And rest 24 bits belongs to identify device in that organization. For example, if your MAC address starting from like this value, then it means that this device is Cisco device. Or you can take a look for the CMD value. If you'll type config ipconfig all, you may see here the description of your MAC address. I mean, you may see here, not the description, you may see here your MAC address. Here it is, A4349 D9. So if you want to see who produced this MAC address of your network interface card, I mean who produced your network interface card, you can just type this OUI A4 34D9. So it's quite enough to see okay, who is the owner of this networking interface card. Here it is. Alright, so I don't see the name of the vendor from here, but maybe I'll see it from this website. Here it is. So the company is Intel Corporate and something like this, and organization Malaysia. All right. So this is how we can find the owner of the network interface card. I mean, the not owner, but the vendor. Let's continue. MAC address is stored in ROM memory. ROM, it is read-only memory. You cannot change it by default. And it is placed, the ROM is placed in networking interface card. So you have computer. In computer, you have networking interface card with its port. So you're connecting with Ethernet. And here we have a ROM memory in which we store the MAC address. And MAC address consists of 48 bits. It is 2 to the power of 48. It is so many numbers, and by approximately of the IEEE, it will be enough till 2100 years, but maybe it is not so, because year by year the statistics and approximations are changed, and this approximate number I took from the book of the 2010 or 11, something like this. And this is how you can see the example. You can find the example of MAC address table. MAC address table can be written with colon, or it can be written with dash, or it can be written with dot. So it can be 3 values dot, 3 values dot, and 3 values, or it can be 2 values dash, 2 values dash, and 2 values, and so on. This is all about the data link layer, which that I want to explain you. I recommend you also to read the book from the material from the netacad.com, which will help you to prepare for your practices and also for your quizzes. If you have any questions, do not hesitate to ask for them from me by using these email addresses, like jamanov@gmail.com and azamatjamanov@sdu.edu.kz. I hope that this video lesson been informative for you, and see you next time.